All right, here we go. Semester 1, Unit 3, the final review. I know there were some questions about, how you do some of this with all the information. So to give you a quick breakdown. So if you have a rational function, so you have information at the top and information at the bottom. So numerator and denominator. Such as, let's say p of x over q of x is something like x squared minus 3x minus 4 over x squared minus 4. So p of x is the top and q of x is the bottom. So they don't just cancel each other out and you have information top and bottom. So the x-intercept, so that's my example I'm going to use for this problem. The x-intercept set the top equal to 0. Factor, solve if you have to. So x squared minus 3x. So solve for x. Okay, so solve for x. Y-intercept, plug in zeros for all x is, and evaluate. So it's really just like you look at the problem, it's really over, any x goes away and it's the constant on top over the constant on bottom. The vertical asymptote, so going up and down, set the bottom equal to 0 and solve. So in this one it'd be x squared minus 4 equals 0. For horizontal asymptotes, we have rules comparing the top and the bottom degrees. Comparing top and bottom degrees. Alright, so if the degree of the top is bigger than degree of bottom, then there is no horizontal asymptote. If the degree of the top was 1 bigger, which we'll get to in a second, on the top than the bottom, then there's a slant. Remember, you don't have a slant and a horizontal at the same time. Degree of top is equal to the degree of bottom. We're going to divide the coefficients and set y equal to the top coefficient over the bottom coefficient. Or the other one, degree of the top is less than degree of bottom. The horizontal asymptote is automatically y equals 0. So the x-axis. Next one is a slant. Only when top degree is 1 bigger than the bottom. So then you do synthetic division. Or long division if you have it. Poles, any factor that cancels top and bottom. Solve for x. And plug in for y. Alright, so this problem right here, I have this information. I cancel out the x minus 2, x minus 2. This means I have a whole. X minus 2 is a whole. So I'm really only working with x plus 4 over x plus 2. Okay, So for the x-intercepts, I set the top equal to 0, so I have x plus 4 equals 0, so negative 4 is 0. For the y-intercept, I have the degree of the top is 1, degree of the bottom is 1, so I have... Oh, I'm sorry, no. Back up. That's for horizontal asymptote. I don't know why I was doing that. Okay, y-intercept. You plug in zeros for all your x's, so I have 4 over 2, so it's 2. Vertical asymptote, I set the bottom equal to 0, so I have it at x equals negative 2. Now I have my horizontal asymptote of 1 over 1, so y equals 1. Slant asymptote, there's none. Remember, you cannot have a horizontal and slant at the same time. It doesn't work. The whole, I already know the x value is at 2. Now I plug it in for the whole. I have 2 plus 4 over 2 plus 2. 6 over 4 is 3/2, or 1.5. Okay, being able to graph these rational functions, slant, be able to identify the plots or the holes and that sort of stuff, and that's it for Unit 3. Thanks.